Welcome, Algebra, to our next video on systems. It is solving it algebraically. It's very different from what we've done before with graphing. We're not graphing at all. We're just doing everything algebraically. And I have a couple special guests today. Austin, you want to say hi?
Hi.
And Grant, you want to say hi?
Hi.
They're going to help me be expert. Yeah, I don't know what I was going to say there. We're going to be experts at this by the time we're done. So we have two learning targets here. We have, I can use multiple algebraic methods to find x and y in a system of equations. It says multiple because there's more than one way, but today we're only doing one way, which is the elimination method. And for those of you in boot camp, you know the deal. We have a lofty learning goal, meaning something we strive for. By the end of the next video is not only can you do both methods, but you can explain without doing any work why one algebraic method is better than the other one. Is that all right? In our first example, we're going to explain why the elimination works, how it works, and all that lovely stuff. Okay, so if you see the big yellow arrow, that is what we're looking for when we have a system of equations that would be very easy to use the elimination method on. So the elimination method is sometimes called the addition method because you are adding two equations together in order to get rid of one of the variables. And to prove it, I'm going to use Austin here. I'm going to ask him a very easy question. I'm going to make up an equation for a number sentence equation. 3 plus 5 equals 8. Would you agree with that, Austin?
Yes.
Grant is going to make up a new number sentence right below it that is just totally unique, different than what I made. Something plus something equals something else. Go for it, Grant. It'd be embarrassing if you got it wrong. Excellent. Now, Austin, help me out. I'm going to add these two number sentences together. What's 3 plus 4?
7.
7. What's 5 plus 3?
8.
Now, what is 7 plus 8? Just for the record, I'm going to let everyone know he's getting his calculator on his phone. 15. Now, did it matter whether I added this way or this way, Austin?
No.
No. Isn't that cool? So our third number sentence that we made up by adding the other two is still true. And that's the premise behind adding two equations together. We'll just get a third equation that is also true. So there's why the addition method, or excuse me, the elimination method works, and I just accidentally eliminated the word addition. Alright, so I'm going to add these two equations together. And it's set up perfectly because when you add a 1 and a negative 1, you get nothing. You get 0, leaving the rest of it just to be added. So this becomes 3y. This becomes 18. So everything has to line up because you can't add x's with y's and y's with constants. They're making fun of my hand movements right now. Alright, so then divide by both sides by 3, you get y equals 6. But we are not done, because what haven't we found yet, Austin? We know what y is.
The x.
The x. We need to find the x. So over here, to find x, use your answer for y and plug it into either equation.
Oh.
Let's go with, what one looks nicer?
The top one.
The top one. So we're going to say x plus y equals 8. If y is 6, Grant, what does x have to be? He wasn't ready for that one.
I was not ready. Oh, it's gotta be 2.
It's got to be 2. So usually the plugging in part is really simple. So x equals 2. Now normally we do a check as well. I'm just going to check it in the one equation we didn't use, just so I didn't lie and didn't do a check here. So x plus 2y equals 10. Hopefully your notes look a little more organized than this. Negative. So we're checking. This is all over the place. Check the point 2, 6. Notice my x is 2, my y is 6, so I write it like that. 2, 6. Negative 2 plus 2 times negative 6. No, not negative 6, just 6. 6. These guys are throwing me off. You're just laughing at me. Negative 2 plus 12 equals 10. 10 equals 10. We did it. Yeah, we just write over everything else. All right.
No worries.
All right, this one says, what do you do when there are no common terms? So in other words, 2x and x, 3y and 6y, they don't have the same coefficient in front. So it's not just a matter of adding them right away. What we have to do is make that happen. We gotta make it happen. So I have a choice here. I could try to make these match, or I could try to make these match. So to do that, I have to think about what I'd have to do to one of the equations to make it match the other one. Grant, pick one of the equations at random.
Well, I'm gonna go with the bottom one.
The bottom one. So I'm going to do something to the bottom one to make it match the top one. Can you easily make a 6 turn into a 3 by multiplying by something?
By multiplying or dividing?
Oh, good one. You could divide it, couldn't we?
That's a lot harder.
But I would rather just stick to multiplying. So could you multiply by 6 to make it, or something by 6 to make it 3? Yeah,
No.
not as easily. But can we multiply 1 by something to make it a 2?
Oh, 2.
A 2. So if we multiply that whole thing by 2, distribute the whole thing by 2, we're going to have a 2x and a 2x. Grant, what happens if you add a 2x and a 2x? What do you get?
4x.
And we want it to go away. So what can I do to the 2?
Ooh, make it negative 2.
Make it a negative 2. So now I'm going to rewrite my original one, my first one that I didn't change. I don't know if I'm too far from the mic here. Sorry for my voice going all out, in and out in this video. And then negative 2x. So I'm distributing here. Want to help me out, Grant? What's the next? So if I distribute, what's this middle term going to be?
That's going to be negative 12y.
All right, and then the last one?
Negative 16.
Good. So we made an equivalent equation. This one and this bottom one, they're the exact same thing. They just doubled it and negated it. All right, now I can add. Austin, what's going to happen right here?
They're going to cancel.
They are going to cancel. That's what we want. When we add opposites, they go away. They become 0. Negative 12 and 3. Anyone?
The 3 is going to be taken away from the y.
Yeah.
It's
Yes.
going to be 9y.
Negative 9y.
Negative 9.
You knew that. And then negative 16 and 7.
Negative 9.
Also negative 9. This works out so nicely. Divide by negative 9. Y is 1. Alright, so we have our y. We need our x. Do you guys remember what to do for finding the other one?
You gotta...
What are we going to do?
Wait. Oh, you just gotta substitute for y.
You got it.
Oh.
Does it matter which one?
No.
Which one you want then?
So the top one.
Top one. 2x plus 3y equals 7. We get 2x. We still don't know x. Plus 3, but now we know y is 1. Equals 7. This is 2x plus 3 equals 7. Subtract 3. It's easy algebra, just kind of annoying at this point. X equals 2. So it's the coordinate.
2.
If we were to graph it, it would meet at, what was it? Sorry.
2.
2. Sorry.
1.
1. And we're going to make this video a little shorter, we're not going to do the checks, but we guaranteed we will do them in class. Alright, we have one more example to do together as a class, and it's one step harder, one notch harder. And it's because I can't easily make a 2 become a 9. I can't easily make this 2 become a 5. So I have to do more than just multiply one of them. So in that case, you have to multiply both of them. Now I have a choice. I could make this become both become something here, or both become something here. Yes, Grant, he has a question.
Oh, no, I was going to answer.
Oh, you got to answer the question. Go ahead. What do you think is going to happen?
Do times 2 on the top one and times 5 on the bottom one.
What is that going to do?
It'll make 10y.
It'll make 10y both times.
So we have to make the 5 negative.
Good, one of them. And yeah, I agree. Let's make that one negative. But would it matter? Could I make the 2 negative instead?
Yes, you could.
Yes, I could. 4x. So I'm distributing here. 4x plus 10y equals 22. Negative 45x. Well, that's a big whoa, big juicy one I was going to say, but we'll get through that one. Okay. Negative 10y equals, and that is 60, I believe. Check my math in the background there. Negative 45 and 4.
Oh, that's negative 41.
Yeah. And then gone. That's the whole point. And then this is 82. It always looks like, how could anything be something that 41 can go into? But it's just because we multiplied by such big numbers. So it does work out nicely. X equals a negative 2.
I just think if I multiplied by 9 and 2.
We could have made them both 18. It would have been bigger. Now we need to find our y. And again, I could use either one. Don't do these. It's just more numbers than we need. We just go back to one of the original green ones here. How about the top? X was crooked. And we plug in 2 times negative 2 plus 5y equals 11. Add 4. This one works out nicely too. Divide by 5. And grant our answer is...
Y equals 3.
So again, our coordinate. Austin, help me out with the coordinate.
Negative 2, 3.
3. You got it. That'll do it. We have one problem that you will have to do on your own. And it is not a fun one. Actually, it's easier than the last one now that I'm looking at it.
Is it really?
Yeah, can you tell why? Can you tell why? Yeah, it's right here. Oh, that's my white marker. This is why it's easier than the other one was. So either way, good luck. And I'll see you next time. Any parting words, guys?
Bye! Good luck.